Hi everyone, Lloyd Rieber here again with our final example in the course Statistics in Education for Mere Mortals. In this video we compute the third of three inferential statistics covered in the course, namely an analysis of variance, or ANOVA for short. The other two were t-tests, one for a correlated samples design and the second for an independent samples design. In both cases, we had two sets of means we were comparing to see if there was a statistically significant difference between them. That is, if the difference was due to something other than chance, such as our teaching, training, or some learning strategy that we invented. The limitation with t-tests is that they can only be used with two means. Well, what if you have more than two means that you want to compare? The answer is to conduct an ANOVA. The ANOVA is based on the F distribution, which is the third distribution we will have discussed in this course, the other two being the normal distribution and the t distribution. I got to be honest and say that I've been looking forward to this video from the moment I decided to do this course. One reason is that the ability to compute an analysis of variance by hand has a reputation of not being for mere mortals, and I wanted to prove otherwise. I think the use of Excel is a true game changer for anyone really wanting to learn what an ANOVA is, how it is done, and most important, understanding the mathematical relationships that lead to interpreting the final result. As we begin, I encourage you to think of an analysis of variance as being like a big jigsaw puzzle. When you know the big picture and have a good grasp of the various pieces, I actually think it's kind of fun putting them all together. But then again, I play an accordion, so what do I know? Frankly, I got to say that as I designed this video, I wondered how many people watching it really will have watched all of the previous videos and completed all of the Excel examples. Of course, I hope a lot, but I know better than that. I'm sure many people who signed up for this course did so for a refresher of statistics that they learned long ago, and I wouldn't be surprised if they made a beeline to this video given how powerful and useful an ANOVA is in evaluation and research. So I'm approaching this video a little differently than the others. Instead of starting by opening the previous Excel file we saved and then building upon it, we are going to do an analysis of variance from scratch. So we will start by opening a new and blank Excel spreadsheet file and build it all in one session. But a warning is in order for those of you who are completely new to statistics and thought you might start here. Stop! I honestly can't see how you can successfully understand what we will be doing here without the necessary background. So go back and work your way through the other videos first. You'll thank me later. Oh, one more word of advice that I hope you will heed. You will need to settle in and take your time for this example. I suggest giving yourself at least a full 2 hours to go through this Excel activity. I almost designed this example in a series of shorter videos, but in the end I decided it was best to do it all in one video due to the way the calculations all build on each other. In fact, once you get into it, I think you'll be pleasantly surprised by how quickly it all really goes. I think in the end you'll save time by spending more time now, and you'll have a richer and fuller understanding. Okay, let's begin with a very short recap of some ideas about an analysis of variance that I introduced in the presentation about inferential statistics. Let's also get acquainted with the key formulas for computing the various sums of squares that will be needed in computing the F value. So the result of conducting an analysis of variance will be the computation of an F value. An F value is a simple ratio of two sources of variance. The numerator will be variance between a set of groups. In our case, we're going to have three groups, divided by the variance within the group. So the pooled or accumulated variance within each of the groups will be in the denominator. A more accurate term for those sources of variance is something called the mean square. And in the numerator, it is the mean square of the treatment, and in the denominator is the mean square of the error. So mean square can be considered as synonymous with the term variance. So let's consider how those two mean squares are going to be calculated. The numerator will be the sums of squares of the treatment, and again the treatment refers to the differences between the groups, divided by degrees of freedom associated with the treatment. And the denominator will be the sums of square related to the error divided by the degrees of freedom associated with the error. Also, the term mean square can be interpreted as the mean or average of the sum of the squared numbers. Now that's not exactly correct mathematically, but I think that's a really good way to think of mean square conceptually. And here is the formula for computing those two different degrees of freedom. So the degrees of freedom of the treatment is the total number of groups minus 1, and the degrees of freedom of the error will be the total number of participants minus the number of groups. There is also the total degrees of freedom, and this will be a very good way for us to check some of our work. As you can see, the degrees of freedom total equals the total number of participants minus 1. And if you add up the degrees of freedom for the treatment and the degrees of freedom for the error, they must equal the total degrees of freedom. And a quick reminder that we have been computing sums of squares all along in this course. And just to go back to one example of the Girl Scout cookie sales, the final column was the square of each of the deviation scores. And recall that a deviation score is a participant's raw score minus the average. Now, in an analysis of variance, it gets a little more complicated than that, because not only do we have sums of squares within a group, but because we have multiple groups, in fact in our case we're going to have 3 groups, we are going to have deviation scores computed between the mean of a group minus the grand mean. And the grand mean is going to be the overall mean of all of the scores across all of the groups divided by how many total participants there are. So let's consider all of the parts and steps to doing an analysis of variance. So I have grouped all of the steps into 4 main parts. Part 1 is to calculate the sum of squares. Part 2 is to compute the mean squares. Part 3 is to compute the f-value. And then part 4 is to interpret the f-value. Now this looks like these are all equal in magnitude, but they're really not. So let me just space them out here to begin to give you a sense of where we'll be spending most of our time. As you can see, most of our time will be spent in part 1, and then quite a bit of time in part 2, and then part 3 and part 4 really won't take us very long at all in terms of actually doing calculations in Excel. However, as we will see, interpreting an f-value will require us to learn a few new skills and a few new ideas. All right, let's consider part 1. And you can see that I've dimmed out all of the different steps here so we can begin to see them and begin to get acquainted with them. But all of the steps would be like all of those puzzle pieces I was referring to in my little introduction. We just need to know where all these pieces go, and once we put them into place, we will have our f-value. All right, let's consider all of the various steps for part 1. So step 1 is to enter participant IDs, group IDs, and raw scores. That'll be very straightforward. Step 2, we'll be doing things we've done in the past, like calculating means for both the group and the overall mean, the grand mean. We'll also be computing n overall and also for each of the groups. Step 3, we'll need to calculate those squared deviation scores. And as you will see, we'll be doing this 2 ways. One, where we'll be using the group means, and another time we'll be using the grand mean. Step 4 will be calculating the total sum of squares. At that point, we'll have all the information we need for that. Step 5, we'll compute the error sum of squares. Then step 6, we're going to be calculating square deviation scores between the group means and comparing the group means against the grand mean. Step 7, we'll have all the information we need to compute the between treatments sum of squares. And then the last step, number 8, will be a mathematical check to make sure that our two sums of squares for the treatment and the error equal the sums of square for the total. Then in part 2, we compute the mean squares. So step 1 will be to determine the degrees of freedom. As you see, we will also use that opportunity to do a little mathematical check. Step 2 will be to calculate the mean square treatment. That will be the numerator for the F value. Step 3 will be to compute the mean square error, which will be the denominator. Part 3 will be to compute the F value simply by dividing that numerator by the denominator. And then part 4 will be to interpret the F value. As you can see, I am again using that divide and conquer strategy to our advantage. Let's take a few minutes to get acquainted with the 3 formulas for computing those various sums of squares. The first one we'll compute is the sum of squares total. As you can see, that is the sum of the square deviations using each of the raw scores and the grand mean. Next, we'll be computing the sum of squares for the error. Now, this formula probably looks a little strange or odd to you in that we have 2 summation symbols. Well, that simply means that we are going to be computing the sum of the square deviations using the raw scores within a group and the respective group mean. So another way of looking at it would be that you have the sum of each of these square deviations from each of the 3 groups. Knowing how mathematical symbolism can get in the way of understanding sometimes, let me just also point out that this T refers to treatment group. When you see it, it refers in general to the idea of the treatment group. So here you have treatment group 1, and then treatment group 2, and then treatment group 3. So G might have been a better label for group, but you will see T for treatment group. And finally, we have the sum of squares for the treatment. Again, T here stands for the treatment group, and the TOT stands for total. So this is going to be the grand mean using all of the scores of every participant across the groups. Now notice that this deviation score uses each of the group means minus the grand mean. So it's going to sum all those up, and you will also notice that we have to include multiplying each of those by the number of participants in each group. So as we take one last look at these formulas, I again just want to point out that the sum of square treatment is a variation between the groups. And indeed, that is evidenced by the fact that we are using the group means as compared to the grand mean in all of those deviation scores. In contrast, the sum of squares for the error is the variation within each of the groups, given that it is based on the variation between each person's score and their group's respective group mean. Both of these sums of squares are therefore the basis for computing the respective mean squares. Finally, we will be able to do a nice mathematical check because the sums of square treatment and sums of square error must equal the sum of square total. I know I always learn best when I put things in a context that I understand. So let's imagine the example we're going to use is a tutorial that we have designed that we are very interested in whether or not graphics are needed. And indeed, not just graphics that aren't moving, which are static graphics, but maybe graphics that are moving or animated graphics. So we would like to compare 3 groups of people going through 3 different versions of this particular tutorial. Group 1 gets the tutorial with animated graphics, Group 2 gets the tutorial with static graphics, and Group 3 gets the tutorial but it has no graphics. We might say it's only text. The null hypothesis in this example is that the three means are all coming from the same population. So we're using mu, the population mean, to represent this, meaning that there really is no difference between all of the individuals going through this tutorial. We would like to reject this null hypothesis if we have an alternative hypothesis that indicates that graphics are needed in the learning of this material, and to go even further, if we had a hypothesis that animated graphics really were the best way to learn this material within a tutorial. So we will use this example in the Excel spreadsheet that we are about to build. Alright, I'm switching to Excel now. Finally. We are going to build this from scratch, but I thought I would give you the lay of the land, and I think this will be very helpful for you to see what the overall structure of the Excel spreadsheet will look like. And what I've also done, and what we will do when we build our spreadsheet from scratch, is we're going to include all of those steps, and we're going to use those as a guide. And as you can see, I put those steps in red with the part title in boldface and all upper caps. So you can see the very first part is where we're going to be entering the participants, the group IDs, and also the raw scores, and begin to do these calculations of the deviations and squared deviations. Now this spreadsheet goes down a bit, so I have to scroll down. And as I go down, you can see I'll be computing the various group means that will be important for us. So that's all in part 1. Part 2 is where we compute the mean squares. And as you will see, we will be using information from part 1 in the computation of the mean squares in part 2. Part 3 is computing the F value. That's a very simple calculation. Again, just a numerator divided by the denominator. Okay, are you ready? Let's get started. Let's begin by opening a new Excel spreadsheet file. Go up to File and choose New Workbook. And let's go and save this right away. Go up to File and choose Save As. We will again save this in the Inferential Statistics folder in our course folder, and we will call it simply our last name dash ANOVA. Make sure it's going to the right folder, then click Save. Now the first thing we're going to do is copy and paste all of those steps for computing an analysis of variance into our spreadsheet. And I put those steps in simple text on the description page for this video. So go to that page and copy those steps and then come back to your spreadsheet. So let me do the same thing. Alright, so right now I am copying and pasting all of these steps. And I come back to Excel and I'm just going to click on the very first cell and choose to paste. And let's go ahead and change the text color of all of those to red. I already have them still highlighted, so I'm going to hit the font color, and if you don't have red already chosen as I do, just go and find red. And then let me click in a neutral spot there because I want to then go and click on part 1 and boldface that, click on part 2, boldface that, part 3 and 4, and boldface those. Let's do a save. I think you'll find having these steps in red will be a wonderful guide as we go through this complicated set of procedures. Let's begin by taking part 1 and steps 1, 2, and 3. So I'm just going to highlight those. I'm going to go up to Edit and choose Cut. And I'm going to leave 4 blank spaces or rows. And so in the 5th row, click on that cell and choose to paste. and that's where we will start. So let's start with step 1. Enter participant IDs, group IDs, and raw scores. So let me skip one row, go to the first cell in the row after that, and let's put in some labels. So I'll write in the label participant, press return, and I really don't want red, so let me click on that label and switch that back to black or automatic. In the next cell, I'll put in the label group, and I'll hit the tab key to go over to the next cell, and I'll type in post test. Next, I'll enter identifiers for each participant. Nothing fancy here, I'm just going to use letters. So let's go to the first cell under the label participant, and I'm going to put in A, then B, C, D, E, F, G, H, I. Let me scroll down here. J, K, and L. So I have a total of 12 participants, and I see we have red again, so I'm going to click on the row headers there and then go up and choose black. Next, we're going to enter identifiers to show which group each participant is in. And we're going to do this in a way that is different from all of the previous videos. The way we're going to do it here is actually going to be the way that will conform to how a statistical package like SPSS would expect to receive this data. It's very simple. So, for example, the first 4 participants are all going to be in the animated graphics group, and we're just going to identify them as being in group 1. So I enter 1 for those first 4 people, remembering that 1 means animated graphics. The next 4 people will be in group 2, or static graphics. So I'll enter a 2 for those 4 people. And then the last group with no graphics, they will be in group 3. Enter a 3 for those 4 people. Now, I don't know about you, but I'm afraid I'm going to forget that. So I'm going to go ahead and put a nice little label up here to remind myself of what those numbers mean. So I'll just type in groups, and then 1 is going to mean animated graphics, 2 will mean static graphics, and 3 will mean no graphics. I think that little key will come in handy later. And I'm sure you're noticing that we are laying out the spreadsheet much differently than in the previous videos. We are putting all of the participants together in a set of rows. We're not putting them as group 1 and then group 2 in different columns. Again, this is how you would enter the data for a package like SPSS. Each row would be a participant, and each column would be a variable. Alright, the next bit of information we need to enter are the post tests. So let's go to the very first participant and enter these numbers, starting with 90 and then working our way down. 80, 70, 75. Moving into group 2, 80, then 70, then 60, then 50. I'm just pressing return after each one. Going into group 3, 45, then 35, then 30, and finally another 30. Let's do a save. And I have to point out that I am following a time-honored tradition in the teaching of statistics of using a very small data set, in this case just 4 people per group, in order to make these relationships among all the different calculations as straightforward as possible. This would not be a good design for a research study. 4 people per group would be totally inadequate. You might ask, what would be adequate? Well, that's a question of doing a power analysis. But a good ballpark answer to that would be somewhere between 15 and 20 people per group would offer reasonable power, I think, for an experiment. Okay, we have finished step 1. Moving on to step 2. Well, calculate n total, grand mean, group ends, and group means. So let's first calculate the total number of participants, and then we can compute the grand mean. So let's come down here to column A. We'll leave a space. We'll put then a label n total. Let's tab over to column C under post test and type in the label grand mean. Alright, so I'm now in the cell below the label n total. Let's go ahead and compute that. We'll start with an equal sign, and you may recall there's a nice function for counting. It's called count A. So type in count A and then an open parenthesis, then choose the range. We go from participant A, click, hold, and drag down to L and close the parenthesis. 12 people in all. Let's go over to the cell right below the label grand mean. We'll type in an equal sign and then the function average, open parenthesis, and then choose all the scores. Click and hold starting on the first 190 all the way down to 30. Close the parenthesis and press return. I have 59.58. We'll do rounding later on. Moving on with step 2, we need to compute the group means and the total number of people in each group. So let's start with some labeling. I'm going to skip 3 rows, come down to the 4th row, and I'm going to type in group, tab over and type n, tab over again and type mean. Press return, and that puts me back underneath the label group, and I'll just put in the group labels 1, 2, and 3. Next, we need to enter the number of participants for each of the groups. So I'll click on the first cell under the label N, and this provides a nice opportunity for a nifty Excel function that will count numbers of cells that have a certain value. So let me just show you by doing it. So you start off with an equal sign, and the function is count if, and open up a parenthesis, and you can see there that it says, well, give me the range and then a comma and then give me the criteria. Well, the range is going to be the entire set of group identifiers. I'll start with the very first one, click, hold, and drag to the very last one. I enter a comma, and then the criteria for group 1 is going to be a 1. Is there a 1 in any of those cells? Close your parenthesis and press return. And it found 4 of them. That's rather nifty. Now let's go back to that function that I just put in, go up to the function bar, and what I want to do is go up and put a $sign in front of the 27 and in front of the 38, because I am going to use the fill down trick in just a second, and I want those rows 27 to 38 to remain absolute. So enter that and press return. As you can see, it makes no change to the first value. Now if I click on that first function there, and now I'm going to click, hold, and drag down to the next 2 cells, go up to edit and choose to fill down. Now we go into the second cell there for group 2 and change that 1 to a 2 and press return. I'm now in the cell with group 3, and I do a similar thing. I go up and I change that 1 to a 3. So all this is doing is looking in these cells right here for those criteria. If it finds a 1, it adds it up for just that particular value. So it's a nifty function, one that I like to use. Okay, and now we compute the means for each of those 3 groups. So let's click on the first cell under the label mean, type in an equal sign, then average, open parenthesis, and we'll just select the post-test associated with group 1, close the parenthesis. In the mean for group 2, same thing, equal, then type average, open parenthesis, but now of course enter or select the scores associated with group 2, close parenthesis, and again for group 3, equal, average, open parenthesis, select the scores for group 3, close parenthesis, and press return. Excellent. We have finished step 2 for part 1. Let's do a save. Now, a good statistician is always aware of the data. So even before we go any further, let's look at those means. And you already may notice an interesting pattern, and that is group 1 has a mean that seems quite a bit higher than group 2, and that mean seems quite a bit higher, much higher than the mean for group 3. Now, we don't have any definitive evidence that those are statistically significant, but it certainly gives me some reason to believe that the between group variance is perhaps showing a difference between animated graphics, static graphics, and no graphics. So something to be aware of. We should always be, again, aware of what the data are showing us. Well, I hope you are feeling deviant, because it's time to compute a whole bunch of deviation scores. Yes, we are ready to move to step 3 of part 1, where we need to calculate square deviation scores for the raw scores using group means and the grand mean. So what does that mean? Let's put in some labels to make it a little bit clearer. Let's go up to the cell right next to post-test in the same row, and let's put in a label x minus lowercase g m, and that will stand for group mean. So x for raw score. It's a little shorter than typing in post-test. Let's tab over, and we need to square that, so I'll put in just a set of parentheses, and then x minus g m, lowercase g, capital M, and I'll put a 2 there. Again, I can't really make that superscript in Excel, but I think I will remember what that means. That's the square of those deviation scores. And then we need to do the raw score minus the grand mean. So let's do all uppercase for GM. All uppercase is much grander than lowercase, so GM, all uppercase for grand mean. Tab over, and the same thing, we'll put in parentheses x minus grand mean, close parentheses, square. So those are just labels. And I'm a little worried again that we might forget what the labels mean. So up here, I'll just type another label to myself, more like a note, that lowercase g, capital M means group mean, and capital G, capital M means grand mean. Excellent. I'm actually going to start with the raw score minus the grand mean. That's going to be a little bit easier. So let me click on the first cell under the label, put in an equal sign, open parenthesis. So x is the raw score, which is the post-test. Click on that first score, minus the grand mean. Click on that. Close parenthesis and press return. Now, I think you know what's coming next, as we're going to be using the fill down technique. So let's click again on that value. We will go up and let's put a $sign in front of C and in front of 41 to make that cell an absolute reference. Press return. Now we can use the fill down trick. Let's go ahead and click on the first score there, first deviation score. Come down to the last cell there for L, and then choose to fill down. All right, let's move on. Let's go ahead and square that. Go to the next cell for the person A, equal sign. Then we click on the deviation score, then asterisk for multiply, and then click on the deviation score a second time, then press return. We have squared it. Let's use the fill down trick. There we go, fill down. Very good. Now let's go over to the deviation scores for the group mean. It's really not that much harder. We're going to do virtually the same thing, but we have to be very careful that we only use the first 4 scores for the first group mean and so on. So let's just do it. Let's press the equal sign, click on the first post-test score, minus the group 1 mean. So let's click on that. It's C46 in my case. And what the heck, I'll go ahead and put in those dollar signs right now between this, before the C and before the 46. Press return. And now I'm only going to do the fill down trick for all of the people in group 1. So let me choose that, fill down. Let's do the same thing now for group 2. Hit the equal sign. The first person in group 2, I'll press that post-test score, minus, be very careful, it's the group 2 mean. And let me go up and I will go ahead and put a dollar sign in front of the C and the 47 and press return. Let's do the fill down technique again, only for the people in group 2. Edit, fill down. One more time for group 3, equal the post-test score for the first person in group 3 minus the mean of group 3. And I will then put a dollar sign in front of the C and the 48. Press return, fill down technique for the people in group 3. Okay, now you might want to go back and double check your work for all of those means. And if I click on the first one, I see that I'm referencing the cell in C46, which is the first group mean. Let me exit out. As I arrow down, I see that 46 remains the same for those 4 people. The next group starts with the next person. I see C47 for those 4 people. And then the last 4 people, I see C48. Last step then is to square those. So we know what to do. Equal sign. Click on the first deviation score. Press a asterisk. Click on the deviation score again and press return. And we can use the fill down technique for all of those. Very good. Let's do a save. Well, we have finished step 3 of part 1. Looks like we need to go back up and get some more steps. Now, as I look at the next step, calculate the total sum of squares, and step 5, compute the error sum of squares, those are really 2 steps that we can do right now. So let's go and select both of those and choose to cut them, so we can then come down and let's paste them. Well, let's go to the same row as the other 2 labels, end total and grand mean, but let's go to the right 1 column from the columns we have been working in, and let's choose to paste them right there. Okay, let's do step 4, calculate the total sum of squares. Let's take a look at the formula. So that is the sum of the square deviations using each of the raw scores and the grand mean. In other words, it's the sum of this column. Well, let's do that. So let's click in the cell that has those other values in the same row. Start by pressing the equal sign. Use the function sum, open parenthesis, then choose the range going from the first value to the last, close the parenthesis and press return. Alright, let's give that a label, SStotal, Press return. Now let's do step 5, compute the error sum of squares. Well, let's take a look at that formula. This was the one with the 2 summation signs. So this was the sum of the square deviations using the raw scores within a group and the respective group mean. Well, that happens to be this column right here. So let's go ahead and sum that up. I'll click right there on the same row as the other values, hit the equal sign. The sum function, open parenthesis, and then the range from the first value to the last, and close parenthesis. And let's give that a label. SSerror. Press return. Let's do a save. Okay, we're rocking now. Looks like, again, we need some more steps. Let's go back up and get some. Steps 6 and 7 go together. Step 6 is calculate the square deviation scores for the group means using the grand mean. And then step 7 is the step where we calculate the between treatment sum of squares, and we could do that after we complete step 6. So let's go ahead and cut those 2 steps. Come on down and paste them in the 2 rows right above where we were computing the group means, right about there. Okay, let's focus on step 6. Calculate the square deviation scores for group means using the grand mean. So what that means is we have to subtract the grand mean from each of the group means. So let's go to the next column. Let's put in a label, group mean, so a lowercase g, uppercase M, minus the grand mean, so all caps, GM. Press return. Alright, that's pretty easy to do. Let's do the first one. Start with an equal sign. So the first group mean, click on that, minus the grand mean. Click on that. And let's go ahead and put dollar signs in front of the 2 parts of the grand mean, right before the C and right before the 41. Again, your Excel spreadsheets might have a slightly different row and maybe a different column. Make sure you're doing it for your spreadsheet. Okay, now we can use the fill down technique to do the other 2 deviation scores. I will click on the first one, then hold and drag as I go down to the other 2. Go up to edit and choose to fill down. Okay, good. Next we have to square that. So let's put a label in. I'll just put a parenthesis. So it's group mean minus the grand mean parenthesis squared. And that's easy to do. I'll start with the first one with an equal sign. Click on the first deviation score times, and I'll click on the deviation score again and press return, and I can use the fill down technique to do the other 2. Alright. Now we're ready to do step 7. Calculate the between treatments sum of squares. Let's take a look at that formula. Now remember that the subscript T stands for treatment group. Remember how we said we wished it was a G. So this part right here, the group mean minus the grand mean squared, well, that's what we have here in this column, but you can see that we have to multiply each of those by the respective number of participants in that treatment group. So it looks like we need another column. So let's put in a label. So N parenthesis group mean minus grand mean squared. Press return. So it's really just this cell times this cell, and the result goes there. So, all right, we are there. So let's hit the equal sign. It will be the n of that group multiplied by, so an asterisk. And then we click on the value right in this column and press return. And we can use the fill down trick to do the others. Fill down. So next we need to sum that up. And let's start by putting in a label. We'll go down right about there. Type in SStreat. Press return. And now we do a summing. So equal sign, sum, open parenthesis, and click and hold on the 3 values to sum. Press return. Excellent. So we have completed steps 6 and 7. Let's do a save. Okay, let's go back up to the top and see what our next step is. Well, there's only one more step before we have finished part 1, and it's step 8, and it says to check to be sure that the sum of square total equals sum of square treatment plus sum of square error. All right, well, let's take that and cut it. Let's go on down, and we'll go right below this area here. So let's click on this cell right below and choose to paste that step. So we just have to make sure that SS treatment and the SS error is going to be equal to the sums of square total. So let's just do a quick check. So I'll go to the cell right below the step, and I will hit an equal sign, and I will click on the sum of square treatment, hit the plus sign, and click on the sum of square error, and press return. And let's compare. Does this number equal this number? Yes, they do perfectly. Excellent. We have passed that very important mathematical check. I think we're ready now to move on to part 2. Let's go up and take a look and see what we are about to do. So part 2 is compute the mean squares, and I see I have 3 steps. Let's start with step 1. Determine degrees of freedom. And I see an important note there about I can use the degrees of freedom total as a check. So let's go ahead and copy the part 2 header, step 1, and the note for step 1. Let's choose to cut. Come on down now, all the way down, and let's give a 2-row buffer there. So I will go to that cell and choose to paste. So it looks like we need now to look at step 1, determine the degrees of freedom. Well, let's take a look at the formula for computing the degrees of freedom. Let's start by putting in some labels so we know what the formula are. So let's start with degrees of freedom for the treatment. So df treat equals, you will see in a lot of statistics textbooks that they will use K to stand for the number of groups. We'll put that in, K minus 1. Press return. Degrees of freedom error equals the total number of participants, so we'll type in n tot for total, minus the number of groups, so minus K. And press return. Degrees of freedom total equals, again, the total number of participants, so n total minus 1. All right, let's go ahead now and do the calculations. Let's start by counting up the number of groups. Now we know there are 3, but let's be a little more sophisticated. Let's go up to where the groups are, and let's put in a label right there below the 3 groups, K. Press return, and then right beside it we'll put in the number of groups, but we'll have Excel calculate that for us. Recall that we have a function called count A. So let's use that. Put in the equal sign, type in count A, open parenthesis, and then we just give it the range, which is these three groups. And we'll use the column that is showing the N. Doesn't really matter. We could use the group identifier as well. The main thing is that there needs to be something in that cell to be counted. Let's put in the final parenthesis and press return. So you should have a 3 there. Alright, these calculations will be a snap. Let's go over to the first open column, and so degrees of freedom for the treatment is k minus 1. So put in an equal sign, click on the k value, 3, and then minus sign 1 and press return. Next is degrees of freedom for the error, so the total number of participants minus k. Alright, let's put in an equal sign, click on the total number of participants up here, that value of 12, minus the number of groups, so click on the value 3 and press return. And finally, the degrees of freedom for the total. So let's go ahead and click on the total number of participants. First, let's put in our equal sign. Then we click on the total number of participants, minus 1, and press return. Let's take a look at this note here that says that the degrees of freedom for the total needs to be equal to the degrees of freedom of the treatment plus the degrees of freedom for the error. And I don't need Excel to help me out here. I can see very clearly that 2 plus 9 is 11. So that's again a very important mathematical check, which we have passed. Let's go up and do a save. Looked like we've run out of steps. Let's go back up and get us some more steps. Well, there's only 2 steps left in part 2. We need to calculate the mean square treatment, and we need to compute the mean square error. The mean square treatment is the numerator for the f value, and the mean square error is the denominator for the f value. So let's add that information to our note or guide. There we go. I bet you didn't know I could type that fast. Okay, let's cut those 2 steps. Select them and then cut. Now let's scroll on down and we'll add those right below our degrees of freedom. So step 2 is to compute the mean square treatment. So let's add a label right there, SStreat. Add another label below that for SSerror. And I am annoyed that Excel keeps doing an autocorrect, and I know I have some others above, but I'm going to go ahead and change that lowercase s to a capital and do the same thing for this one. And I'll correct those others above in my spreadsheet later when we're all finished. Well, let's check the formulas for computing the mean square treatment and the mean square error. The mean square treatment is equal to the sum of squares for the treatment divided by the degrees of freedom for the treatment. So let's start there. I will click to the cell just to the right of the label for mean square treatment. Then I'll press an equal sign, find the sum of squares for the treatment, click on it, divided by, so a / degrees of freedom for the treatment. Click on that value of 2 and press return. The mean square error is the sum of squares error divided by the degrees of freedom for the error. So I will go, I guess I need to scroll up just a little bit here. There we go. I will start by hitting an equal sign, click on the sum of squares for the error, divided by, so a / degrees of freedom for the error. Click on the value of 9 and press return. Excellent. And I am going to put in a little label here just to point out that this is the f numerator, and I'll also put in a note that this is the f denominator. And I think I'll go ahead and make those red. Let's do another save. Well, I am so close to being done, I can almost taste it. Let's go up and see what is left to do. Well, we have two more parts, part 3 and part 4. Part 3 is compute the F value. Let's go ahead and do that. This is a very simple calculation, but let's take that comment and cut it, bring it on down, and let's go, we'll leave 2 rows there as a buffer, and we will paste that. Alright, let's go down 2 more rows. I'm going to type F value, press return. So we just need to divide the mean square for the treatment by the mean square for the error. Let's do it. Equal sign, mean square for the treatment, / divide by mean square of the error, and press return. So I have a F value of 20.74, and then we have some rounding off to do. Let's check our work. To do so, I use the statistical package called SPSS, and I put in all the raw data and ran the analysis, and here is the ANOVA summary table. Now I'm going to scroll up just a little bit so that we have all of the main values that we need here to compare. In fact, I'm going to go up here and I'm going to boldface these key areas, these key labels. Alright, a few more. So these are all of the values that you see represented in the ANOVA table. Now let's take a look and see if we have an accurate analysis. The first thing we better check is our F value. So we have a value of 20.741. According to SPSS, it should be 20.741. All right. Let's just check the other data points. So in our ANOVA table, we have the sums of squares. So between the groups, 4004.167, and that matches it perfectly. Sums of squares within the groups, 868.750. And of course, we already know that that equals the total, but it's nice to have confirmation. The degrees of freedom, you can see how they match very nicely, the ones that we have as well. And it almost goes without saying that our mean square treatment and mean square error matches that in the table. Now there's only one question remaining, and that is this a significant difference? And the SPSS table gives it away. It is most definitely a significant difference. 0.000 means that it's out there a few more decimal points before we'll actually see a number. So it's definitely going to be breaking through that threshold of 0.05. Now the only thing that tells us is that the 3 means do not come from the same population. Therefore, the 3 means are different. Now it doesn't tell us where the difference is. Are all 3 means different? Is only one mean different than the other 2? If so, which one is it? So we do have a little bit more work to do in order to interpret that F value. Let's go back up to the top so that we can cut and paste our last main step. I'll cut that. Let's go back down to the bottom. And let's paste it right about there. There are 2 fundamental questions that we have to answer in order to interpret the F value. The first question is, do the populations that these three treatment groups come from have the same mean, or are they different? And I'll write that simply as, are the means of the treatment groups the same? The second question is conditional based on the first. So if the answer to the first question is no, which is the same as rejecting the null hypothesis, then the question is which of the treatment means are different from each other? Let's go ahead and put those into red. I'm going to scroll up a little bit so I can see all of the group means. And as I eyeball the data here, we can see that it really is a very good question. I'm rather confident that the 78.75 is going to be significantly different than the 35, but is it significantly different than the 65? Likewise, is the 65 different than the 35? So if you think about it, we have a bunch of comparisons to do between those three means. In fact, we have three. We're comparing 1 and 2, 1 and 3, and 2 and 3. Now, conceptually, you might be thinking to yourself, hey, great, I know what to do. I know how to run t-tests. And conceptually, you're on the right track, but you really can't just do that. And here's why. Recall that we have a significance level of 0.05, which means that 5 times out of 100 we expect to incorrectly reject the null hypothesis. That is, to say that we have a statistically significant difference when in fact we don't. And basically every time you run a t-test, you add this 0.05 probability to the overall probability of making this error. In an analysis of variance, that's called the family-wise error rate. So to run 3 t-tests means that you are potentially increasing the significance level to 0.15 or 15 out of 100, which we know is not acceptable. But statisticians are clever people, and they have come up with something called multiple comparison tests. These are very special tests that will do these multiple comparisons of these means while controlling for the family-wise error rate. Okay, well, let's start at the beginning. Let's assume we don't know the SPSS output and we want to at least answer question number 1, are the means of the treatment groups the same? So similar to the t-test, we need to look up the critical value in a table. With an analysis of variance, we need to use 2 degrees of freedom, the between groups, which in our case is 2, and the within groups, which in our case is 9. Then we will look up the critical value for the F value to see if our 20.741 is equal to or greater than that critical value. So let's do that next. And here is one such table. I found this on the internet and I will share the link to this with you. So let's start by putting our information down below here. We have degrees of freedom equal to 2 and 9. And we have an F value equal to 20.741. Okay, so the first degrees of freedom we use going across the top, and the second we use going down the side. And you do notice also that we have the significance level set on this table to 0.05. All right, let's go down and find the intersection of those 2 values, and we see a critical value of 4.2565, and I would say definitely this is a significant F value. So the answer to question 1, are the means of the treatment groups the same, is a resounding no. So we can reject the null hypothesis and then move on to the question, well, which of the treatment means are different from each other? So this is now a question of running multiple comparisons among the treatment means. And to answer this question, we are not going to compute this by hand. Instead, we will refer to SPSS and run a multiple comparison among the means that is called a Tukey HSD. And HSD stands for Honestly Significant Difference, a name that never fails to bring a smile to my face. And here's a table of the output from SPSS. And there's a lot of information here, but what we're interested in is the information contained right in here. The output is showing all of the different comparisons. So for example, we're seeing a comparison between groups 1 and 2 right there, and a comparison between groups 1 and 3 there. Groups 2 and 1 there, groups 2 and 3 there, groups 3 and 1 there, and groups 3 and 2 there. So there's some redundancy, obviously, but notice that over here you'll see a little asterisk to show which of the comparisons are significant. And indeed, if you look at those asterisks and then go over to the column for significance, you will see which ones are equal to or less than 0.05. So it looks like we have significant differences between groups 1 and 2, 1 and 3, and also 2 and 3. And so we have means here that are significantly different from each other. So in this particular case, we can make the inference that animated graphics are superior to static graphics, which in turn are superior to the use of no graphics in this particular tutorial. An important note, by the way, all of the data I used in this example were hypothetical. Now, I don't expect you to have access to SPSS, so the evaluation in this course will stop with the calculation of the F value. But I hope you have a good initial understanding of what's involved in interpreting the F value. Okay, well, let's do a few final housekeeping chores and then we'll do a final save. Let's start by going up to the top of our spreadsheet, and we have a lot of empty space now, so I'm going to select all of those rows that are empty and choose to delete them. And I'm not going to do it here, but I probably will after I end this video. I am going to go back and change these labels so that I do have all uppercase SS. And you might have noticed too that in my prototype I had some nice color bands to separate the different parts, so you might want to go back and add that as well. But I would like to go and do some rounding, so let's go to the areas that need to be rounded to 2 decimal places. So this section right here, let's go up to Format, Cells, Category Number, 2 decimal places. Okay. Come down to this section right there. Same thing. Format, Cells, Category Number, 2 decimal places. Let's not forget these areas right here. Format, Cells, Number, 2 decimal places. Sum of squares for treatment. Format, Cells, 2 decimal places. And finally, this section right there. And there we go. And let's not forget now to do our last final save. And believe it or not, this finally concludes the computation of a one-way analysis of variance.